Today we are going to go over a method of solving quadratics called completing the square. We know how to solve quadratics by factoring. We've solved quadratics by taking the square root of both sides. If those don't work, then what we can do is called complete the square. Our first thing that we need to go over for completing the square is we want to try to find a perfect square binomial. Perfect square trinomial. Then we are going to write that expression as the square of a binomial. For instance, the first example, x squared plus 6x plus c. To find what c will equal to make it a perfect square trinomial, what we do is we take half of 6, so we take our b, because this is standard form, ax squared plus bx plus c. We take half of b, or b divided by 2, and square it. So here, b is 6, 6 divided by 2 is 3, 3 squared is 9, so c equals 9. So that would make this perfect square trinomial x squared plus 6x plus 9. Now to write that as a square of a binomial, what that means is we're going to have a binomial and it's going to be squared. We take that half of b. b divided by 2 is 3. So for this next one, I have x squared minus 30x plus c. So I want to find out what c will equal to make it a perfect square trinomial. So we can label that a, b, and c. So b over 2 and square it. So negative 30 over 2 equals negative 15. And then square that. Negative 15 squared is 225. Then to write my square of a binomial, half of negative 30 was negative 15. This is going to be very important to figure out for completing the square. The next example, a, b, and c. So b over 2 squared. So negative 24 over 2 and square that. So negative 24 over 2 is negative 12. We square it, we get positive 144. So now to write my square of a binomial, half of negative 24 is negative 12. Now sometimes we may not have our b, when we divide it, it may not come out to be a whole number. So in this case, b over 2 squared, so b is 7 over 2, square it. So you could take 7 divided by 2 and get 3.5, then square that. Or you could just leave it as an improper fraction. So 7 squared is 49. 2 squared is 4. I could leave it as an improper fraction. So I could write my square of a binomial as 7 plus 7 over 2. Or you could do x plus 3.5. Okay. How to complete the square. Okay, you could read through all of these steps, but I'm going to talk through it. Okay, and actually all these steps will be on each example. First step, divide everything by a to make a equal 1 if necessary. Well, go ahead and label your numbers right now, a, b, and c. A, it's 1 right now, so we don't have to do step 1. Step 2 says move c to the other side of the equal sign if necessary. C, we want that to be all by itself. So I'm going to subtract 1 from both sides. Now I'm going to set up my equation. X squared minus 10x plus something equals negative 1 plus something. We don't know what those numbers are, but what we did for that second slide by taking half of negative 10 and squaring it, that's where we're going to get this number. So what's half of negative 10? Negative 5. So negative 10 over 2 is negative 5, then square it. So you should get 25. Now I'm going to write my next step as to be the square of a binomial. So just like the second part, we write our square of a binomial. X, half of negative 10 is negative 5, equals negative 1 plus 25 is 24. So we found that question mark by taking b divided by 2 and squared it to get 25. Now we change the left side to a perfect square, our square of a binomial. Take the square root of both sides. So the square root of x minus 5 squared is just x minus 5, plus or minus. Now radical 24, we can break that down to 6 times 4, and 4 is a perfect square. So I can bring a 2 out, 2 radical 6. Now you're wondering, there's other numbers that multiply to 24, like 8 and 3, 12 and 2. But those aren't perfect squares. I use 6 times 4 because 4 is a perfect square. Okay? Then last but not least, it says solve for x. So that means get x all by itself. So I subtract 5. Now I don't have any terms to combine it with, so the negative 5 goes out in front, plus or minus 2 radical 6. It's the same procedure for these to solve a quadratic by completing the square. You just may have different numbers. At any point, please pause the video to catch up, to follow along, and work these problems out. Step 1 for this problem, divide everything by a to make a equals 1. A is 1 right now, so I don't have to do step 1. Step 2 says move c to the other side of the equal sign if necessary. Well, I need to get c all by itself, so negative 4. And then we can set up our equation. X squared plus 6x plus something equals negative 4 plus something. Now, what you could do is you could go and set up your next step of the equation. Half of 6, take b divided by 2. So 6 divided by 2 is 3, and square it. 3 squared is 9. Well, half of 6 was 3. Okay? You could, go ahead and set up your next step, because once we take half of 6, take b divided by 2, 6 divided by 2 is 3, then square it. That's 9. That's what we put in those plus somethings. That's what we didn't know. Now we can take the square root of both sides. So I have x plus 3 equals plus or minus radical 5. Can you break radical 5 down farther? No. So you just subtract 3 from both sides. So I have x equals negative 3 plus or minus radical 5. This next example, step 1 says divide everything by a to make a equals 1. Well, a is 3 right now. So we need to divide everything by 3 first. So these cancel out. So I have x squared. 12 divided by 3 is 4x. Minus 6 equals 0. Step 2. Move c to the other side of the equal sign, so add 6. So I have x squared plus 4x, and I'm going to go ahead and set up my equation, plus something equals 6 plus something. Now I could also set up my next equation, okay, or I'm sorry, my next step. It's that square of a binomial. Half of 4 is 2, and square it. 2 squared is 4. So I get 10. Now I'm going to take the square root of both sides for completing the square. So I get x plus 2 equals plus or minus radical 10. I can't simplify radical 10 any farther, so I get x all by itself by subtracting 2. So x equals negative 2 plus or minus radical 10. Okay, so there's sometimes you may not have sometimes you may have a problem where it's already set up for you. Okay, where your C is on the other side. Okay. Now writing in vertex form is pretty much the exact same thing. What we will do is we will set it up. Y plus something equals. Now I'm going to separate x squared minus 10x plus something plus 22. All I did was separate it from our first two terms. Now I'm going to go set up my next step of the equation, which is just like completing the square. I'm writing my square of a binomial. So now we do the same exact thing to find these numbers. Half of negative 10 is negative 5. Now square that number and that will be your C. Because b divided by 2 squared. Negative 10 divided by 2 is negative 5. Negative 5 squared is 25. Now we have to write it in vertex form. So I need to subtract 25 to get the y all by itself. So I have y equals x minus 5 squared minus 3. Now if we remember, we need to identify the vertex. My vertex, my x, is the opposite of the number inside the parentheses, so positive 5. My y of my vertex is that last number, the same. So 5, negative 3. So remember, pause the video at any time. I will go through this last problem. So y, I'm going to set it up, y plus something equals. Now I'm separating x squared minus 8x plus something. I'm separating that from 17. So now I'm going to set up my next step because it'll just get me going. So all I have to do is plug numbers in. So b divided by 2, negative 8 divided by 2 is negative 4, and then square that, that'll give you your C, so 16. All I have to do now is subtract 16 from both sides to get y all by itself, and then I'll have it in vertex form. So x minus 4 squared plus 1. Now my vertex is the opposite of number on the inside for my x. The last number stays the same. Completing the square and writing the vertex in quadratic, or writing the quadratic in vertex form, pretty much the exact same thing. You just have to follow the steps. Write your quadratic as a perfect square trinomial and then a square of a binomial. Have a good day.